So hello friends, welcome back to our channel Adamya Education. So this is the second video of the chapter force, and today we are going to learn what is couple and what are the uses of couple in our day-to-day lives. Also we will learn about one of the most dreaded questions by the students of class 10 related to the principle of moments. So let's begin. So what is a couple? As the name suggests, couple is something which is in the form of pair, but in case of force, couple is a pair of forces which will act along two different directions. Although they are parallel to each other, but the direction is different. That means if one is directed along this direction, the other has to be directed along this direction. Okay. So two equal and opposite parallel forces not acting along the same line, that means they are acting along two different lines, they are known as couple. And whenever we want to perform any rotation, like for example we want to rotate the cap of a sauce bottle, or we want to rotate the steering wheel, always couple is essential. We are going to understand that through the diagram. So we, as you can see, have taken two examples. First of all, turning of a bottle cap, and the second one is turning of a steering wheel. There are many other examples, like you are turning of the knob of something. In that case also couple is utilized. So let us see how does this work. So we know that whenever we want to open a cap, as you can see, the person has placed his fingers in such a way. The thumb finger will apply a force in this direction and the forefinger will apply a force in this direction, isn't it? So as you can see that the forces are parallel to each other, but they are opposite. They are not along the same line. So this is a couple. And in order to open a bottle, you have to rotate the cap in such a way that from your thumb a force is getting applied in the forward direction, and using your forefinger you have to apply the force in the backward direction. Similarly, when a person is driving a car, the steering wheel has to be held by both the hands, or even if the person is holding it by one hand, on one of the surfaces the force will be in this direction, and on the other part the force will be in this direction. As you can see, again these two forces are parallel to one another, but they are along the different lines. That means this is also a couple. So whenever you have to rotate an object, you always require a couple for that purpose. So friends, over here I have a glue bottle which I want to open. So I'm going to explain couple using this. So as you can see, when I'm trying to open this, I have to use my thumb and my forefinger both, but in two different directions. The force applied by them will be in two different directions. Just see. The forefinger is applying the force in the direction of the camera like this, and the thumb is applying the force in the direction of the wall. That means they are parallel, but they are in two different directions. So this is a couple. So now our next topic is moment of couple. So we are going to do a small derivation over here. As you can see, I have taken a rod AB which is pivoted at the center O, and at A there is a force F which is getting applied in the downward direction, and on the surface B, or on the point B, there is a force which is getting applied on the upward direction. And since the forces are same, that means rotation is occurring in the rod. Now if we want to consider the moment of force at point A, we have to take the distance AO, because O is the point of pivot. Similarly, if I want to find out the moment of force at point B, I have to consider the distance OB, because O is the point of pivot. So the moment of force at point A, the moment of force, we know moment of force, that means torque, will be equal to force into the perpendicular distance from the line of action, that means F into AO. Okay. Similarly, now if we want to consider the moment at point B, so at point B we have the moment as force into OB. Alright. Now if you want to find the total moment in this couple, this is a couple because same forces are getting applied, they are parallel, but they are in two different directions. So what will be the total moment of this couple? It will just be the sum total of this moment and this moment. So our total moment is F into AO plus F into OB. So from here, if we take F as common, we are going to get AO plus OB. AO plus OB, that means the entire distance AB. That means our required moment is force into the total distance. Okay, so either force into the perpendicular distance between the 2 points where the forces are applied. Okay, so this is almost similar to torque, but over here we are going to consider two forces at the two ends of the rod or of any other object. Hope it is clear. So our next topic now is equilibrium of bodies. This is a very important topic because based on this we are actually studying physics. So what is equilibrium? When a number of forces acting on a body produce no change in its state of rest or of linear or rotational motion, the body is said to be in equilibrium. That means just consider we have an object over here. We are applying a force of 10 Newton in this direction, and from the other direction also we are applying two forces. One is 8 Newton and one is 2 Newton. That means in the left hand direction also 10 Newton force is getting applied, and in the right hand direction also 10 Newton force is getting applied. So will the body move? No, the body won't move, because the forces which are applied on it will completely cancel out each other, and as a result the body will remain in a stable condition. So this is known as equilibrium. Now what happens in case of a moving car? There is force of friction between the wheels and between the road, which is trying to pull the car backward, or you can say which is trying to stop the motion of the car. Also there is air resistance, although it is not that high, but still we will consider it. Now what happens, in order to keep the car moving, the driver has to accelerate the car, or the person has to keep on steering the wheel along with producing acceleration, right, in the forward direction. So in order to keep the car moving, the forward force has to be greater than the backward forces, or the force which is applied by the person, that has to be greater than the resistive forces. So in this condition also we will say that equilibrium has occurred if the car continues to move. Now if after some time the car stops moving because of deceleration, or because the person is stopping the car, that is a different issue. But until and unless the car is moving, that means all the forces which are acting on it is completely becoming nil. There is no effect of a single force, but total force is propelling the car in the forward direction. So in case of a moving object, the same thing happens. So equilibrium is also of two types. Let me explain that to you. So the first type of equilibrium is known as static equilibrium. As the name suggests, it is the equilibrium of an object which is at rest. Like if you keep a book on a table, it won't move because of its mass, because of the normal reaction. Also there is another type of equilibrium which is known as dynamic equilibrium. In this case, if a body is moving, then it will keep on moving because of the equilibrium of the forces on it. For example, when an aeroplane is flying in the sky, why doesn't it fall down? Although there is a gravitational attraction because of the earth, but also there is a force called the buoyant force, which you have learned in Archimedes principle, because of the air which is surrounding it. As a result, it is lifted above the surface and it can continue flying. So whenever an object is at equilibrium, always all the total force should be cancelled out by the others. Hope this topic is also clear. Now there are certain conditions for equilibrium to occur. Like I told you, the resultant of all the forces which are applying on the body should be equal to 0. That means each of the force should cancel each other, so that no net force is getting applied on the body. The sum total of all the forces, or you can say the resultant of all the forces, will be equal to 0. Also, the algebraic sum of the moments of the forces acting on the body about the point of rotation should be 0. That means clockwise and anti-clockwise moments should be equal. Only then the object or the body will be at equilibrium. For example, if you consider that you have pivoted a meter rule at the 50 centimeter mark, what happens? 50 centimeter mark is its midpoint, and over there is no clockwise rotation also, there is no anti-clockwise rotation also, because the moment which is anti-clockwise in nature and also the moment which is clockwise in nature, both are equal and opposite. As a result, they are getting cancelled out. So these two are the conditions for equilibrium. Very important questions are asked almost every year related to this. Now there is another important topic related to this principle of moments, or you can say this condition for equilibrium. Like I told you, clockwise and anti-clockwise moment has to be equal. For example, let us consider this is our rod, this is our meter rule AB, and it is pivoted at this point O. If I place an object like this, what will happen? The meter rule will move in this direction, or you can say the meter rule will fall towards this direction, right? So will you consider it to be clockwise or anti-clockwise? It is moving like this. That means it is anti-clockwise, right? Now if you remove that object and now you place an object at B, there is no object at A now. So what will happen? The meter rule will tilt towards B. So the movement will be somewhat like this. That means this is clockwise movement. So depending upon the clockwise and the anti-clockwise movement, in order to create an equilibrium in case of a meter rule or in case of any such rod, the clockwise movement and the anti-clockwise movement has to be completely equal to one another. This is what we are going to discuss in the next class, and also we are going to do those numericals which I was talking about. So I hope you have understood whatever we have done in this class. Hope to meet you soon. Thank you everyone for listening.